As I told you, okay, this week, I told in the group already, I told you before this week. So I will do this uh China Selangor 2025. Okay, I probably discuss structural questions, and then the answer question I will discuss in extra class on during weekends. Okay. So then next week, July week 1, I will enter Form 5, Chapter 5. Okay, I will enter Form 5, Chapter 5 next week. Yeah, next week. Okay. So this week, I take the opportunity to discuss uh Selangor paper 2025. Okay. So yeah. And then in this case, by the way, for those who Selangor paper Amali tomorrow, I send the group already lah, so you can check it out. Okay. So for those who need, maybe your school already discussed, maybe if you still don't know anything come up, for Selangor Amali, you can check it out. Okay. So yeah, I send the group already. So in this case, okay, let's look at this. Selangor paper, question 1. Let's jump to it. Okay. So, what chapter is this? This is Form 4, Chapter 8, right? Alloy, glass, ceramic, composite material chapter. Okay. So yeah. And then they ask actually material X, actually, this one is alloy Y. Right? They didn't point properly. So alloy W. Okay. So this one is a car body. Car body made up by alloy W. And then not duramin. Okay. So material X actually point towards actually the front part. Okay. Point towards this. This is the car bumper. I think the diagram a bit off. Okay. So this is the car bumper. Yeah. So they ask, see, I tell you, right? Material X, material X made up of Arian. Who is Arian? Okay. So in this case, okay. So what about this? Name material X. Material X made up of glass and plastic. What is material X? Actually, material X is one of the composite material you learn in 8.4. Okay, so no. Okay, you got 5. Superconductor, reinforced concrete, photochromic glass, fiberglass, optical fiber. So which one is this? The car bumper made by fiberglass. It's a stronger version of plastic. Stronger version of normal plastic. Yeah. Okay. Can make your racket, small boat, car bumper, helmet, this kind of thing. Okay. And also tanki, water storage tank. What advantage? You can just say very easy. This one stronger, or you can say harder. Stronger, you can say harder. Okay. Next. Okay. Taiwan shows alloy W and its components. Can I put high stretching strength? No. Okay. So high stretching strength is for the reinforced concrete. High stretching strength, high compression strength is for reinforced concrete, not for fiberglass. Okay. Table 1 shows alloy W and its components. Okay. So 90 contain alloy W contain 98% of iron, 2% of carbon. Okay. Yes, they told you alloy W used to manufacture body of car from table diagram one. What is alloy W? What is alloy W? Alloy W is a stronger version of pure iron. What is alloy W? It's not the car body. Okay. As long paper, for those who enter, okay, I told you in the group already. Okay. So this one is, who can tell me? Who can tell me? Iron add with carbon to form what alloy? What's the name? What's the name? Hey, nobody know. Steel. Thank you very much. Chào quý. Steel. Okay. Explain why alloy W is harder than pure iron. My teacher made us do this in quarantine today. What do you mean? Do what? Do alloy. This question, huh? Really? Oh, damn. Wow. I didn't. Okay, that I didn't expect. Yeah. But I can't expect that because normally your school teacher will repeat those questions. Okay, your school teacher did everything. No, right? Quarantine. Why you go quarantine? Why you go quarantine? Yeah. So explain why LW is harder than pure iron. This is kind of funny actually. Okay. So if I know early, then I will do other question. Arrangement of proton atom, yes, correct. 1 mark. What is the other mark? So what is point one? Presence. Ui, of foreign no, not easy to slide when force is applied. Yes, very good. Amalima cannot leak. Because Amalima cannot. Ha 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 ha. Cannot leak. I don't get it, but yeah. What does it mean by Amali? Ha ha ha. Cannot leak. Yeah, I know. You told me Amali, but this paper. Then what is related to this paper? I'm curious. Okay, so for instance of foreign atoms. Okay, what happened? Disrupts the the orderly arrangement in pure method. Then point two is yes, this orderly arrangement of pure iron, correct. And then second, it is difficult for the layers of atoms to select over one another when force is applied. Okay, this chapter quite popular, so not so popular, but will come lah sometime. So your teacher did 3 essays. Got time? I mean, actually can. If fast, then can. Because I feel like this paper is not very hard. Okay? Actually, maybe the essay question slightly challenging. Okay, then give paper and ask us to do only no discuss. Huh? Also, you got hard copy already. Literally. No discuss one. Will discuss or no discuss? Will discuss or haven't discussed? No. Child, child care. Oh, I heard. Child care is 13 July. First week, Teras writing paper, Amali speaking, continuous elective subjects. Oh, okay, interesting. Okay. Second, nope, do with friends. Oh, okay. So diagram 2 shows the atomic structure of sodium. Okay. But I think today one hour cannot finish 11 questions. Okay. So the essay questions most probably I do, or maybe it's question 7, 8, 9, 10, 11 I do extra class during weekend. Okay, so I'll upload to YouTube later. So sodium atom has three subatomic particles, namely proton, electron, neutron. Name the lightest subatomic particles. So you untung lah. So I teach lah. Okay. So in this case, okay. So you see, they give you structure of atom, 11 proton, 12 neutron. How many electron? I'm marking my paper now. And 11 electron, because you see, first shell got 2, second shell got 8, third shell got 1. So 2, 8, 1. Okay. So name the lightest which one? Subatomic particle. Normally the answer subatomic particle normally is proton or neutron or electron. So lightest is it's not easy lah, electron. Write the standard representation of sodium. How to write number based on this? Yes, okay. So remember, 11 proton plus 12 neutron, you will get nucleon number 23. So on top you write 23, below you write proton number. Sodium, the symbol is Na. Yes. Okay, very good. 3. Sodium 24 is an isotope, meaning isotope. Okay, let's see. Who remember? Wait. Yeah. Wait lah. Why I feel like a bit laggy one. Meaning, not the uses yet. Meaning. Meaning of isotope. Atoms of the same element that has the same number of protons but different number of neutrons. I mean, you literally like Form 4 Shadow 2, right? But I'm going to tell you this is Form 4 Shadow 2. Okay? Yes, very good, Sri. Okay? It's basic, you have to know, right? Maybe this year, your Selangor paper, I don't know, can come out of meaning of nuclear number, meaning of proton number. Maybe slightly change. Okay? Okay. Say the number of neutrons for sodium 24. Many students, you write for me 12, okay, but it's not 12. Okay, so it's 13, yes. Because this is sodium 23. Sodium 23 has 11 proton, 12 neutron. Sodium 24, 11 proton, 13 neutron. So be careful. So the answer is 13. Then you can say use of this radioisotope. So you can just say to detect the leakage in underground pipes. Not but I think I saw a lot of people came out sodium 24. Okay. 3. This one is Form 4, Chapter 5. Okay. Based on diagram 3, write the electron arrangement of atom X. Okay, ion X. X plus actually. Ion X plus. What is the electron arrangement? Ion X plus. Positive charge. 2, 8, 8. Right? For sure, man. Normally ion you achieve stable, right? But how about atom X? What is the electron arrangement? 2881, correct. 2881. Okay, after donating electron, become 288. Okay, so and then Y? What is atom Y? Okay, after become ion Y minus, also 288. But normally when you receive electron, so at the beginning is 287. Receive one electron, become 288. Receive one electron, this one donate one electron. So what is this compound? What is the type of compound? No, this is ionic compound, got charge, brother. This ionic compound got charge. Got charge always ionic, no charge always covalent. Okay. This between a metal and a non-metal. Who can tell me? Actually, who can tell me what is X? What is element X? Then I call the person Paul. Who can recognize what is element X? Potassium, very good, Jiahui. Okay, yes, potassium, exactly. Okay, what is Y? It means K will form K plus, donate one electron. Chlorine, yes, they become chloride ion. Yes, Cl receive one electron becomes Cl minus. Okay, or you can say here is Y receive one electron become Y minus. Okay, so it means you know that this is group 1, this is group 17. Okay, so what is the electron arrangement of atom X2881? Write the equation. How to write? Who can tell me? When they will form XY, right? 1X, 1Y. How to write the chemical equation? Oh, this is a very common student mistake. Okay, normally I saw the answer is like this. Example, there's one person here told me this. Right? If you put like this, 0 mark. I cannot change, I cannot put charge. Yeah, I didn't ask you to put charge. No, it's not charge. It's not the problem of charge. Many students, okay, always make this mistake in equation. You think properly. Group 17 is what? Okay, Jahwe already wake up. Okay, so this halogen. Halogen exists as diatomic molecule. Normally is fluorine, chlorine, bromine, iodine. Normally they are not singular at all. Normally they are molecule. You don't write Cl only, you write Cl2. Yeah, you always forget, always. Okay. Y2. Ah, they always catch you this. This problem. Okay. I mean, it's okay, but better if your exam don't this mistake. Because very common. Okay, I saw this. It means you have the balance, right? Because left side got 2y, right side times 2, right side got 2x times 2. Very common, right? Including oxygen, don't forget. Oxygen also O2. But sometimes exam they don't like to give you O2. They like to give you unknown. So you have to know there is oxygen, there's chlorine, right? Yourself. No, you have to know yourself. Of course, answer scheme also can be like this. Since you know X is potassium, Y is chlorine. So answer scheme can accept this. Okay. Molecule Q consists only of element Y. The physical properties of molecule Q are as follows. Okay, exists as greenish yellow gas at room temperature. Okay, has low boiling point. Okay, you know what is formula for this Q for molecule Q? Only got Y, only got chlorine, right? So it means this is chlorine Cl2. Cl2. It means chlorine will share electron with chlorine. What is this bond? What is this compound called? Now it's covalent, yes. Finally. Draw. Okay. So you draw lah. Okay, so you got Q. You can also draw Cl, nothing problem. You can put inside, you can put Q, you can put Cl, nothing wrong. No, not Q, sorry. You can put Y. They talk about element Y, isn't it? Or if I know chlorine, I still put chlorine. Cl, three shells, 287. Then the first, you can put X. Second, you can put dot. Oh, one more here. You have to show the share pair of electron. Okay. Teacher can both be accessed. No, better not. Better not because you have to show different. I mean you have to show the share pair of electron. Better if you show one x one dot to differentiate. Okay. Actually, nothing wrong, but it's safer if you put different. Okay. Okay. Safer, I think it's safer. So that your teacher, sometimes very strict one, right? So better follow. Okay, move on. Can both are 287. Just overlap each other. Question 4. This is Form 4, Chapter 3. Diagram 4 shows the information about urea fertilizer. Urea fertilizer is essential in modern agriculture to supply nitrogen needed for optimal growth of crops. Okay, so based on diagram 4, they give you molecular formula for urea is CO bracket NH2 bracket 2. State the meaning of molecular formula, which is one of the common things, isn't it? Either they will ask meaning of empirical or molecular if they come on this chapter. So your answer is chemical formula that shows what? The molecular is an actual one, actual number of atoms of each element in the nucleus, and not in the nucleus, but sorry, of each element in a compound. Sorry. Of each element in the compound, yes. Okay. Very good job. That's okay. State the empirical formula of urea. So you see the ratio of carbon to oxygen to nitrogen to hydrogen is 1 to 1 to 2 to 4. So do you think it can simplify? Become empirical? No. So what is the answer? It's the same, isn't it? Yeah, it's the same. It's kind of a free mark. Okay. If you know, okay, right? Just copy them. And not everything, sometimes you have to divide. Okay. And in this case, yes. Same answer. Name all the elements, another free mark. Name all the element. C stands for carbon, O stands for oxygen, N stands for nitrogen, H stands for hydrogen. This is free mark, free one. Of course, you have to know the name, right? Ammonia reacts with carbon dioxide to form urea and water under high pressure at 180 degrees Celsius. Write a balanced chemical equation. What is formula for ammonia? NH3. Don't forget, NH3. Okay, if you forget, then this full mark gone. Okay, and the following also gone, right? Because you have to count number of more, right? So, and then plus carbon dioxide, CO2, urea, just now they give you formula, CO bracket, NH2 bracket 2, water, H2O. But don't leave it like this. Check is it balanced or not. You see, at the right got 2N. At the left got 1N. So times 2. Now you can check again. 2 times 3, 6H. 2 times 2, 4. 4 plus 2, 6. Okay, balance. O is 2. Right side 1 plus 1, 2. Okay, settle. C also 1. Okay. Calculate the mass of urea if 42 dm³ of carbon dioxide reacted with ammonia. So mass of, what is the information here? What they asking you to find? Mass of urea. Which one is urea? This one. So you have to put below mass equals to question mark 42 dm³ of CO2. Which one is CO2? This one 42 dm³. It's so easy, right? So always start with the one that has information first. What is the first one that we can use? Number of mole of carbon dioxide equals what formula? dm³ stands for what? Volume. Okay, volume. Molar volume given also 24. So you can straight away use volume over molar volume. 42 divided by 24. What do you get? One point 75. Very good. Mole. And then do ratio. Okay. So 1 mole of CO2 ratio to 1 mole of urea. So 1 to 1. So it means if you got 1.75 mole of carbon dioxide, you also get 1.75 mole of urea. And then another formula, number of mole equals to, since you want to find mass, so mass, it means mole equals to mass over molar mass. Mole, I means if you want to find mass means mass of urea, number of mole multiplied molar mass. Number of mole is 1.75. Molar mass for urea give you a 60 on top. Yes, you get 105 gram. Okay. You get 105 gram. Okay, done. So I contain 2 marks. It means for this point, they didn't count the mark of the ratio, unfortunately. Okay. Fifth, this is Form 5, Chapter 4. We just learned not long time ago. Okay. So the following structural formula, I mean, literally we learned last week and before last week. Okay. The structural formula shows the monomer of natural rubber. Name the monomer according to IUPAC name. Now, if it is common name for the monomer of natural rubber, it's called isoprene. But hey, this diagram is a bit funny. Okay, I'm sorry. This diagram is a bit funny. Second carbon got CH3. First carbon got 2H. Ah, yes. I saw the correct answer. Okay. IUPAC you have to follow the yes, the methyl part. Okay. This is the methyl, remember? The CH3 at the second carbon, I told you, the branch, okay, the branch at the second carbon. And then this is the 4 carbon in a chain. The 4 carbon is called butene, but because you got 2 double bonds at the first carbon and the third carbon, that's why it's called 2-methyl but 1,3-diene. Very good. This is 2-methyl. This is but 1,3-diene. IUPAC name cannot write isoprene. Cannot. Ali, a rubber taper, discovered that the latex he collected from the rubber plantation will coagulate if exposed to air for a certain period of time. Explain the phenomena above. 3 marks. Exposed to air. What happened? Air contain what? This one I told you not long ago. I think literally last week. I mean before last week. Lactic acid come from where? Who produced lactic acid? Bacteria and air. Yes. Very good. Okay. So the first point is bacteria from the air. What does it do? enters into latex and secretes lactic acid. Okay, this one I think we'll just still hope you get fresh memory. Point two, acid contain what? Ion. Okay, hydrogen ion from acid. What does it do? Neutralize what? Remember the protein membrane is what charge? Neutralize the negatively charged protein membrane. Okay, very good. Protein membrane, not proton membrane. Okay, neutralize the negatively charged. Important point. Huh? Then point three. Uh, then when they neutralize with it, then they become neutral particles. Okay, neutral rubber particles collide. Remember, after they neutralize, no more repelling to each other, no more repulsive force. Then you start to collide each other, collide with one another. What happens if keeps colliding? Causes what? Causes the protein membrane to break. Very good. Okay. Rubber. Then apa? Rubber polymers combine and latex coagulates. Yeah. 3 marks. Hey, last year Selangor paper come up. This literally what I just learned. Not long ago lah. Okay. This part you can remember, right? Yeah. Okay then. Oh, here for wrongly already. Negatively charged. Okay. 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 Suggest a suitable substance to prevent the coagulation of latex. Explain your answer. Now they want to prevent. If normally, if you want to speed up coagulation, you add acid. If you want to prevent means, what do you add? What do you use? You use alkali. Okay. If you want to speed up the coagulation, you add latex. I mean, you add acid. If you want to prevent coagulation, you add alkali. What alkali? What example? Ammonia solution. Very good. Okay. Very good. Very good. Okay. Ammonia solution. Explain. 1 mark. So, ammonia contain what ion? Ammonia có ion. Alkali có ion. OH minus hydroxide ion. Yes, very good. Okay. So hydroxide ions from ammonia solution will Okay, you can say that. You can say neutralizes any hydrogen ions from acid. Okay, center. If you go further explain, you can say that the negatively charged remain, then repulsive force remain. The particle will not collect. Okay. But since too much already, then you can just say 1 mark for substance, 1 mark for explain. You can just say this. C. Diagram 5 shows the process to modify this one literally written last week. Okay. Natural rubber. Okay. So you see at the beginning, you got a lot of the rubber contain a lot of double bonds. Okay. After undergoes process X, which you add disulfur dichloride. Okay. Then you will get this rubber that has been modified contain this bond. Okay. No more double bond. What is this bond called? Remember? The sulfur cross-link. Remember? So what is the process called? Vulcanization. Very good. Vulcanization. To make the rubber become stronger, more elastic. That's why one advantage can have many answers. Okay, you can get 5 different answers. Okay. So what are the answers? One advantage, so simple. You can say stronger, harder. You can just say more elastic, more resistant to heat, more resistant to oxidation. Many answers. Many choices. Okay, easy, right? I don't think it's quite very hard. Yeah, especially after you just learn, right? About connection. But if you forgot this chapter, then it's hard. Okay, so question 6. This one is Form 4, Chapter 4. Diagram 6 shows the flow chart. Okay, for the reaction of chlorine. What is the group for chlorine? Chlorine is group 17. Yes. This shows the chemical properties of group 17 actually. What chlorine can react with? Okay, 3. They show all the 3. Okay, number 1, react with water to form hydrochloric acid and hypochlorous acid, HCl and also HOCl. Okay, which is HCl is acidic, HOCl is contain bleaching properties. Okay, it's like a Clorox, remember? Can turn your shirt become white color. Okay. Second, add compound P. Chlorine add compound P, you will get sodium chloride, sodium chloride 1, and then OCl, and H2O, water. Okay. So, and then third, react with iron. Okay, before that, P. What is P? Okay, I saw 3 answers already. So fast. Okay, very good. NaOH, NaOH, Jeffrey, very good. Okay. Yes, correct. The answer is sodium hydroxide. Or you can straight away put NaOH. Very good. Can it means chlorine can react with alkali, can dissolve in alkali. Okay, can dissolve in water, can dissolve in alkali, can burn with iron. Yeah. State the observation when blue litmus paper is placed into the product of the reaction between chlorine and water. This is acid, right? So, what happened? Yes, I saw the answer. Yes, very good. Yes, yes, yes. Got study, got study. Turn red only not enough. Turn red not enough because you got this. Yes, turn to red and bleach. Or you can say turn white. Or turn white or bleach can. White or bleach. Yeah, these two. Chemical equation between chlorine and iron. So it means they ask for compound X. And remember, this one is when chlorine react with iron. Iron is iron atom, but chlorine is a very strong oxidizing agent, able to turn iron to Fe3 plus. So it means when Fe react with Cl2, and remember chlorine Cl2, you see it came out two questions in this. Okay, so you will get Fe is 3 plus, you get iron 3. Cl is 1 minus. So the formula is FeCl3. Yeah, remember cross, positive 3, negative 1 cross, become 1 Fe, 3 Cl. And then balance equation. How to know whether plus 2 plus 3 when they give only iron? Oh, in this case, you have to know form 4, chapter 4, in this case, chlorine can straight away turn Fe to Fe3 plus. This form of chapter 4. Chlorine can straight away turn Fe to Fe3 plus. Can straight away turn to brown solid. By the way, this is brown solid. So only chlorine teacher, so others all positive too. Normally Fe change to Fe2 plus, correct. You are right. Okay, but in this case, in this experiment, yes, Fe you turn to Fe3 plus. But normally you learn in redox, normally Fe turn to Fe2 plus. Yeah, but this chapter they straight away turn to Fe3 plus. Okay, balance equation 2 times 3, 3 times 2. Then right side got 2 Fe times 2 for Fe. Okay. Yeah. Reactivity of chlorine with water is higher compared to bromine. Write the chemical equation for the reaction between bromine and water. Now, just now they give you is chlorine and water. Now they change to bromine and water. Okay, but the way they write is same. Okay, so you just change this to Br. The product same. Okay, around the same. So you will get Br2 plus H2O. For those who still confused, it's like this. You can split the Br into 2. You can split the H2O into H and OH. Then you get your first product, HBr. Second product, HOBr. So you got HBr, HOBr. Explain why there is a difference in the reactivity between chlorine, bromine, and chlorine. So they already told you, right? They already told you the sentence. Okay, chlorine, reactivity of chlorine in water is higher compared to bromine. Why chlorine is more reactive than bromine? First point is what? Remember about what? The size, the atomic size. This one, okay, also popular. So below BR, no mark. Okay, so you have to say size smaller. Okay, so you can say first point, atomic size of chlorine atom is smaller than bromine atom. No, don't have the word atom wrong. Okay. Second, P2, P2 you can say the nuclear attraction force towards the electron. You remember nucleus in the middle? Because chlorine is 287, the electron arrangement. So chlorine want to attract one electron into the valence shell. So chlorine is easy because the nuclear attraction force is stronger compared to bromine. Okay? So nuclear attraction force towards the electrons, okay, towards the electrons, and towards the valence electron, I mean valence electron okay, okay, in chlorine, okay, I add towards the valence electron in chlorine atom is stronger than bromine atom. Point three, it is easier for chlorine atom to accept an electron into the valence shell compared to bromine atom. Okay. Actually, it's a very standard format. Okay. So when one element reacts, it has to attract electron, not donate electron. Depends on what element, Mister. Not every element is attracting. This one I'm talking about. I'm talking about group 17, ma. I'm talking about bromine, chlorine. Okay. If it's potassium and sodium, they're different. Then you have to say donate, right? You have to say potassium. It's easier for potassium to donate one electron. Okay. Balik. Need to write to achieve stable octet electron. Can I? Can I? But in this case, I think answer scheme didn't give you this one. Can, right? Nothing wrong. But you can continue to achieve stable octet electron arrangement. But actually, in this case, no need. I don't see the mark. Okay. Can, right? But it's not the one that determine the mark. Can, right, also? Okay. So that okay. So question 7. I think today only do until question 7. Question 8, 9, 10, 11 I will do in extra class. Okay. So three sets of experiment. Maybe like I think like Saturday or Sunday night. Okay. Three sets of experiments are carried out to determine the factors that affect the rate of reaction. Table 7 shows the reactants and the time taken to collect 40 cm cube of gas Okay. Important, okay. Later you have to use for maybe for calculation, for drawing, right? So yeah, see, set one uses this one in Form 4, Chapter 7, real reaction. Okay. So set one uses 30 seconds, set two uses 50 seconds, set three uses 90 seconds. Okay. So set the meaning based on table 7, set the meaning of real reaction. So what can you say? So normally, what do you say? Increase volume increase, right? Of course, volume of gas collected increase. Right? So you can say increase in the volume of what gas answer? What gas? You see, if HCl, okay, if HCl react with calcium carbonate, what are the products? CaCl2, H2O, and CO2. Right? So the gas is carbon dioxide gas. Yes. So it means here to say that, okay, increase in the volume of carbon dioxide. Why might become like this? Carbon dioxide gas per unit time. Of course, okay, you can also write if you want, okay, change in the quantity of carbon dioxide gas per unit time. Actually, can be accepted, can be accepted, okay, or you can say decrease, okay, in the mass of calcium carbonate per unit time. But normally, of course, I recommend first one. Recommend first one, of course. Okay. Normally, we don't measure the mass of, decrease the mass of CaCO3. Normally, more accurate is the volume. State two factors that affect the reaction. So, what can you say? Based on this, based on this. You know, this was the difference. You see set 2 and set 3. What is this? Size. You see set 1 and, set 1 and set 2. Concentration. Okay, so you can say that. 1, size of, you have to say it's size of what? If only size wrong. Size of what? Calcium carbonate. No size wrong. Don't have the letter name wrong. Size of calcium carbonate. Full thing. Okay. Second, concentration. Cannot just write this concentration of what? What are they changing? Concentration of hydrochloric acid. Full. Calculate the maximum for CR. Calculate the maximum volume of gas released in set 1. So they give you the information. Set 1, acid 25 cm cube, volume 0.4 mole per cube, molarity. So of course, this one I give you 25 cm cube, 0.4 mole per cube. Carbon dioxide means volume equals to question mark. So of course, first step, 3 mark, right? Simple again. First step, number of mole of HCl equals to mv over 1000. M is 0.4, volume 25 over 1000. Zero 0.01 mole. Ratio 2 mole to 1 mole. 2 to 1, 2 mole of HCl to 1 mole of CO2 means you have to divide by 2 lah. If 0.01 divided by 2, you will get 0.05 mole of CO2. Means another formula is number of mole equals to volume over molar volume. If you want to find the volume of CO2 means number of mole 0.005 multiply molar volume 24. You will get 0.12 dm cube, okay, or 120 cm cube in this case. Okay, so I think I saw today the rest of the question, okay, including question 7E, 7 donkey, 7E, question 8, 9, 10, 11, I'll do it in extra class. Okay, so thank you for coming. I'll see you again next week. Goodbye, everyone. Okay, bye bye. Okay.